Okay, Assalamualaikum. Today, my team and I will talk about secondary storage structure. Before we know about that, we must know that secondary storage structure is not directly connected to the CPU. Just as an example, memory like RAM, random access memory, has its own bit buses connected directly into CPU. Second, secondary storage structure needed today is long term. There is no volatile storage available. That means data is kept then power is turned off. Third, term to know about secondary memory is 1. Capacity. 2. Durability. Third, speed. There is two aspects of speed in the theory. Storage are bandwidth and latency. Then cost. After that, portability. Finally, reliability. There is a fixed disk drive is likely to be more reliable than a removable disk or tap drive. We will move on to the overview of my storage structure with my mate Alif. Izzuddin bin Dzali, ISM SKPP students, semester 2. Now we are going through to the overview of my storage structure. First of all, we are going to the magnetic disk. What is magnetic disk? Magnetic disk provide bulk of secondary storage of modern computers. Then, magnetic disk transfer rate is rate at which data flow between drive and computer. Then, the positioning time, which is random access time, is time to move disk on to desired cylinder, which is seek time, and time for desired sector to rotate under the disk head, which is rotational latency. Then, after that, head crash results from disk head making contact with the disk surface, which is that's bad. After that, this can be removable in this magnetic disk. Finally, the drive attached to the computer via input-output bus. That's all from me. Thank you.
Hi, my name is Danish, Qayyum. Today I'm gonna explain you about magnetic disk. Okay, magnetic disk was early second storage medium and relatively permanent and holds large quantity of data. Access time is very slow. Random access time is 1,000 times slower than the disk. Very slow for some reason. Maybe because second storage medium. So mainly used for backup and storage of frequent data use. Data transfer between system. Okay, only 20 and 200 typical storage that can hold. Okay, I'm gonna pass this explanation to my mate. I will call Danish. So let's go.
My name is Zulkafli. I'm from ISM PP Sem 2. So for this structure, first of all, these drives are addressed as such one-dimensional arrays of logical blocks. So where the logical block is, the smallest unit of transfer, as we know that the one-dimensional array of logical blocks is mapped into the structure of the disk sequentially. For the second sector is 0 is the first sector of the first track on the outermost and cylinder. Okay, and lastly, mapping proceeds in order through that track, then the rest of the tracks in that cylinder, and then through the rest of the cylinders from the outermost to innermost. Okay, that's for all for me. So the next I will pass to my my members. It is Amin, so I will go. Sorry.
So, for the next topic, I will tell you guys about this attachment. So, about this attachment, is host attached storage access through I/O ports and talking to the I/O buses. Then we have network attachment storage. Network attachment storage, or else we can call it NAS, is storage made available over a network rather than over a local connection, such as a bus. So next we have this scheduling. This scheduling is network attached storage, which is also called NAS. That is a storage made available over a network rather than over a local connection, such as a bus. So there is 5 types of this scheduling, which is FCFS, SSDF, scan, C-scan, and C-loop. So I will explain you guys about it next. So firstly we have FCFS. So for FCFS, it's called first come first serve. So basically here, as you can see, it has started about 53. Then we have for first come first serve, we must start whatever the number that comes first in the queue, we have to start with it. So after 53, we have 98 here. Then we have 183. Then we have move backward into 37. Going back to 122. Backward again into to 14. Then move forward to 194. Then the second last is 65. And finally we have 67 as the last point. So you can see the movement, it moves according to the queue given. So next we have SSDF. It's called shortest 6 times first. So according to the same queue that was given, the head start will be 53. So for SSDF, we must take the lowest value distance between the numbers. So for SSDF, we start with 53, then we move forward to 65 because that's the less distance to go between each queue. So 53, 60, 65, then move forward to 67, then we go find the shortest distance between the queue, which is 37, 14, and going forward to 98, to 122, then move forward again to 134, then finally 183. So for SDF, basically you must find the shortest distance between each queue. So for the third, we have scan. So we follow just the same. We can start for scan. We start with 53, but for scan we move backwards straight to 0. Which the number in the queue are the closer to 0. We start over. So we have 53 as the head start. Then we move to 37, 14, and we stop at 0. Then after that, when there is number not less than 53, doesn't have it, okay, then we start moving forward. So after 0, we start forward. It's 65, 67, 100, 98, 122, 134, then finally 183. So for scan, we just move backward until 0, then move forward until the endpoint, until the largest number in the queue. Okay, for the fourth one is a C scan. So C scan. For the previous one is scan, which is move backwards, but for the C scan we move forward. So let's start with 53, then we move forward to 65, 67, 98, 122, 124, then move forward until 183. But for the scan, we move backward until 0, but this one is move forward, so we must move forward until the end, which is 199. And after that, we don't have, if we doesn't have the number exist after the 53, then we move backward to the 0 back, which is 0 here. Then we move forward to 14, and finally is 37. That's all for system. We move forward until the end, then start over with 0. So for the final one is silu. For silu, for the silu, we must start with move forward, but it doesn't have end to 199, but it just stop at the highest number in the queue. So we start basically at 53, then move forward to 65, 67, 98, 132, 134, move to the highest number in the queue, which is 103. Then after that, we move backward into the smallest number, which is the 14, and finally is 37. That's all from me for this scheduling. Thank you.
Okay, I'm back. But now I will talk about this management. First, we must know that this management is a low-level formatting or physical formatting. It divided this into sectors that the disk controller can read and write. Second, this management is used disk to hold files, where the OS or operating system still need to record its own data structure on the disk. Third, partition the disk into one or more group of cylinders and logical formatting or making a file system. That's all for disk management. Thank you.
Okay, here we are again. Now we're going to swap space management. What is swap space? Swap space is a situation when a virtual memory uses disk space as an extension of main memory. Then we're going to RAID structure. What is RAID structure? RAID is multiple disk drives, provides reliability via redundancy. Then RAID is arranged into 6 different levels. That's all.
Hello. Oh, okay. You guys can. Okay. I'm gonna talk about stable storage implementation. Okay. Right ahead, log schemes require stable storage. To implement stable storage, replicate information on more than one non-volatile storage media with independent failure modes. Okay. The third is update information in a controller manner to ensure that we can recover the stable data after any failure during data transfer or recovery. Okay guys, I need to go. Hello?
It's already late. Okay, 3 p.m. Okay, so for this, we have 2 different discs. The first one is removable disc. Removable disc is like optical magnetic. So for the worm disc, it's a little bit different that write once, read many times, and such as CD, ROM, DVD. So for tape, we can compare to a disc. The tape is less expensive and holds more data, but random access is much slower. So that's all for me. If you guys enjoy this video, give it a like, comment down below, and don't forget to share.
Hello? Hello? We busy right now.
Bye.